Hi friends, welcome to classes by Lab Doctor. In today's class, let us discuss about the function of this HDL. So you all know that HDL is the good cholesterol and LDL is the bad cholesterol. If at all the HDL cholesterol is more than 60 or higher, it is very good level of HDL. And if the HDL cholesterol is less than 40 in men and if it is less than 50 in women, we call it as dangerous level of HDL cholesterol. So why is this HDL so important? This HDL is a anti-atherogenic lipoprotein. So this has various functions. It is anti-inflammatory, it is antioxidant, it increases the nitrous oxide production, it is vasoprotective, it is anti-fibrotic, anti-thrombotic, it helps in the cholesterol efflux. So there are many functions through which it protects our heart, it protects our blood vessels, it prevents the formation of this plaques in our arteries, in our vessels. That is why this is a good cholesterol. This is a good cop which helps and protects our body. So let us start to analyze what is the main function of this HDL. So remember, HDL has two very important roles. One is the reverse cholesterol transport and second is the inflammatory action of this HDL. So now this reverse cholesterol transport and the anti-inflammatory action, both they prevent the atherosclerosis. You all know that atherosclerosis starts with the damage to the blood vessels, the endothelial damage, the inflammation, the excess of lipid formation, which all triggers this kind of an inflammation. So the culprits or the nidus is inhibited by this HDL. So these are the main two functions. So let us see what is this reverse cholesterol transport. So HDL's primary function is to facilitate the reverse cholesterol transport. What is this reverse cholesterol transport? See, the lipids, the lipoproteins, they will take these lipids and they will go and deposit it or give it to the peripheral tissues, the skeletal muscles, your adipose tissues, wherever they will need the fat, they will give it. Once they have used, the excess of it is cleared, it is cleaned from the bodies, from the cells, from the tissues, from the blood vessels by this HDL. So this cleaning part, the scavenger is this HDL. So this reverse, it will carry the excess of whatever is left over, it will carry it back to the liver. It will not leave it there. So this is called as reverse. It is carrying back cholesterol transport. So it is carrying the cholesterol back, the excess cholesterol it is carrying back from the body cells, tissues, etc. So this reverse cholesterol transport, it is having different steps. It includes basically removal of this cholesterol from the tissues to the liver, and subsequently this is excreted from the body. So no excess of cholesterol, lipids, etc. should remain in the body, and the excess gets excreted. Why is it important? Because if this reverse cholesterol transport mechanism doesn't happen, the excess of lipids will be floating, they will be lying there. What they will do, they will start damaging your blood vessels, they will start building up these plaques in the arteries, and then you will get this atherosclerosis, heart block, etc. So that is why this becomes very important. So this is like a scavenger, the van wherein it will carry this excess of cholesterol, etc., and take it to the liver. The liver will metabolize it and excess will be thrown out. So that is why it is very important. So now how this works? So I have told you that the cholesterol is first transported from the cells to the peripheral tissue, and to do that you will require your lipoproteins. What are your lipoproteins? Your LDL, VLDL, HDL, chylomicrons, all these things. Now HDL, why it is called good cholesterol? Because it will pick up the excess of cholesterol from the cells. Now whatever the cells have taken, they have taken it, and what they don't want, the remnants whatever are there, they are not allowed to stay there. They will be picked up by this HDL. It will then transport it to the liver here, and now this HDL will bring it back to the liver, and the liver will then excrete it eventually in from the body in the bile, through the feces or the stools what we pass, that will have the excess amount of this cholesterol which is processed by the liver. So this is the liver, and here you will see that the apoA-I which is produced by the liver, the small intestine, they will form this HDL. apoA-I is the important apoprotein in this HDL. So this HDL, what it will do, it will take the cholesterol efflux happens from the tissues, that is the excess of cholesterol whatever is there from the tissues, from the cells, it will carry this from the tissues into the plasma. Here you need a protein called as this ATP binding protein, which plays a very important role. So this once it is thrown out, the cholesterol which is efflux, so you can see these are the free cholesterol. So what it does here, LCAT enzyme, lecithin-cholesterol acyltransferase, this helps in the esterification of this free cholesterol into cholesterol esters. So this cholesterol esters you can see here. So this, once it is done here, this cholesterol esters are transferred by this cholesterol ester transport protein. So this cholesterol ester transport protein will transport these cholesterol esters from this HDL to LDL, and this LDL you can see that it moves into the liver. This is the LDL receptor, and here also you can see this is the scavenger receptor B1. This is the receptor for this HDL, which helps in the two-way movements of this fatty acids or the lipids inside the liver and the HDL. So once this reaches the liver, this cholesterol is excreted. The excess of cholesterol is excreted from the liver as fecal sterol. So through the bile acids, it is excreted through the stool. So that is how HDL would help. So this HDL, I have told you that it will prevent the formation of these foam cells. Foam cells are nothing but these are the cells or the macrophages which are eating up the excess of lipids, and they start the inflammation. So they are being prevented by this HDL. So the main players here would be your HDL, definitely, because it is the main player which is helping in the reverse cholesterol transport. Then you have this ATP binding cassette, which I have told here, which is a protein which helps in the initial step of the cholesterol efflux. Then you have this lecithin-cholesterol acyltransferase, which helps in the conversion of this free cholesterol to cholesterol ester, and this scavenger receptor, which facilitate the uptake of this cholesterol ester. So these are the key players here. So same thing you can see here. So how the LCAT has converted the free cholesterol into cholesterol esters, how the transport protein, cholesterol ester transport protein, is transporting it to the liver, the form of LDL, VLDL, etc., and how the liver is utilizing that free cholesterol and excreting it through the bile or through feces. Whenever there is low level of this HDL, the efflux or the removal of this excess cholesterol becomes very slow, and if it is very slow, they might build up in the blood vessels and then may lead to the formation of plaque formation, arteriosclerosis, etc. So what is the implication of this process on the heart health? Because I have told you this HDL removes this excess of this lipids, excess of this cholesterol, etc., from the tissues, from the cells, etc. When they are not removed, there is formation of these foam cells, there is formation of atherosclerotic plaque, there is inflammation, etc., and that is going to damage the heart, because it is going to damage the vessels of the heart, and that is going to have impaired blood supply to the heart. So good level of HDL will be cardioprotective. It will do its job well. It will remove the excess of cholesterol, the lipids, etc. It will prevent the inflammation of these vessels, and hence it is cardioprotective. This HDL has an anti-atherogenic effect. One is it will prevent the inflammation also. It will inhibit the expression of this adhesion molecule, so that these monocytes, the inflammatory cells, don't adhere here, and also it will inhibit the formation of this foam cells, and that is how it will prevent the formation of this atherosclerosis. So atherosclerosis is inhibited by this HDL through various mechanisms. It inhibits oxidation of this LDL proteins, it inhibits the inflammation, it inhibits the activation of the vascular endothelium, coagulation is inhibited, platelet aggregation is inhibited. So these are the inhibitory properties of HDL, and you all know this is important because the main nidus for this atherosclerosis is this damage to the endothelial vessels. So there will be no endothelial dysfunction. It will prevent the endothelial dysfunction. Hence the nidus, the starting point of this atherosclerosis is prevented. It will prevent the inflammation, immune system activation, so that there is no inflammatory response. It will prevent the coagulation, platelet activation. It will also prevent the lipid oxidation. So these are the inhibitory functions of this HDL. So it also helps in the redistribution of the lipid. This is what I was telling you, that wherever it is excess, it will remove it from there. Wherever it has to reach, it will see that the lipid is reaching the cells, the peripheral tissues, etc. So the next important property of this HDL I have told is an anti-inflammatory property of this HDL, and I have told you that it inhibits the expression of this adhesion molecule, so that none of these inflammatory media starts getting adhered here, and also it will prevent the formation of this foam cells. Foam cells are nothing but the macrophages which eat up this excess of cholesterol, and then they start the inflammation. It is also an antioxidative because it will prevent the oxidation of this LDL. So this is how it will prevent the inflammation. It will see that the inflammatory mediators are stopped. It will see that the nidus of inflammation at the blood vessels are stopped, so that it will prevent the LDL from oxidation, etc. Because once the LDL gets oxidized, it will change its property. It starts getting accumulated into the foam cells. It will start the process of inflammation, etc. So all this are done by this HDL. So you can see here this anti-inflammatory effects of HDL. So this is the endothelium here. So it will prevent the oxidization here. It will prevent the adhesion of these molecules, the inflammatory cells. So this HDL, it is acting as an antioxidant. So it will prevent the LDL from getting oxidized, because once the LDL gets oxidized, there will be changed structure of this oxidized LDL, and it will damage the cells more. So it is an antioxidant, it is an anti-inflammatory, prevents the inflammatory cells from getting adhered to the vessel wall. It is immunomodulatory. It will help in the endothelial cell repair also. So that is also, it will prevent the endothelial dysfunction. It is anti-thrombotic because it is anti-platelet, prevents the platelet aggregation, prevents the coagulation. It helps in the production of nitrous oxide, which is a vasodilator. So here you can see this is the atherosclerotic plaque here. So the vessels will be damaged, and then comes the inflammatory mediators whenever there is damaged vessels, and then comes the smooth muscle proliferation, and then the eat this excess of lipids, here comes the foam cells, and here these are the foam cells. They are forming a plaque. So all this is prevented by this HDL. HDL tries to avoid majority of these steps, so that this formation of this atherosclerotic plaque is prevented by this HDL. This HDL, it helps to maintain the health and function of this endothelial cells, and because of which it will prevent the endothelial dysfunction. And once this is prevented, there is atherosclerosis which is prevented, there is thrombosis which is prevented, there is prevention of the plaque or the plaque rupture, restenosis, etc. The HDL has an anti-thrombotic properties. One is directly it will inhibit the platelet aggregation, and if that is done, there is reduced thrombus formation. And indirectly, how it does this anti-thrombotic property is it will release this nitrous oxide, and this nitrous oxide is the one which causes vasodilation, and also the prostacyclin I2 which is released, which are the platelet activator inhibitors. It will also modulate the thrombin generation, and it will help in the synthesis of this prostacyclin, which again inhibits the platelet aggregation. So nitrous oxide production I have told you, because this nitrous oxide is very important for vasodilation and cardiovascular health, and this increased nitrous oxide production by this HDL contributes to the cardiovascular health, including your vasodilation, preventing blood clot, protecting against our atherosclerosis. So this is what I was telling. This is a nitrous oxide production. Here this is an anti-inflammatory action by preventing the adhesion molecules. This is anti-thrombotic effect. It is preventing the platelet from aggregating here. Anti-apoptotic action, so that the vascular endothelial integrity is maintained. It will see that the excess of cholesterol is removed, so that there is no formation of these foam cells, etc. It will prevent the oxidization of this LDL, so that it will not damage the cells here and start forming these plaques. So all these are the functions of your HDL. So, HDL acts as a good cop, a cop which cleans up the city. So similarly, HDL is a good cop which will clean up our body, which will clean up our blood vessels. So it has vasoprotective function. It will protect our blood vessels. Anti-inflammatory effect, so it will calm down. It will see that the inflammation is reduced. It will help in the reverse transport from the peripheral tissues to the liver, so that there is no excess of cholesterol, lipids lying around and causing inflammation. So it acts in the clearing up of the excess cholesterol, so that it doesn't form the atherosclerotic plaques. It will prevent the oxidation of LDL, because if it does get oxidized, it is going to cause damage to the endothelium and the blood vessels. It will stimulate the production of nitric oxide, so that there is vasodilation, there is no platelet aggregation. Directly it can prevent the aggregation of platelets. It is having anti-atherogenic properties. It is having an anti-apoptotic properties, because of which it is called as a good cholesterol. It is called as a cholesterol which is going to protect our heart, and we want the level of this HDL cholesterol to be high. The high density lipoprotein should be in higher levels to protect our heart. That was all about the functions of this HDL, or why HDL is called as a good cholesterol. Thank you so much for watching the video. Please like, share and subscribe the channel. Thank you.